All right, let's move on to another discussion on centroids. And what I want to do is find the centroid of this composite shape. Okay, and I'll talk about what I mean by composite shape here. So the idea here is we have a trapezoid, but there's been a hole cut out of the trapezoid. So this circle represents a hole that's been cut out of the trapezoid. And I want to find the centroid of that trapezoid now that the hole's been taken out. And what we really want to focus on here is the fact that a centroid is based on an integration, and an integral is a sum. Super important. An integral is a sum. And so to find the centroid of this, I'm going to take the sum of the shapes that I know. And so if I look into the back of the book, I can break this shape down into three shapes. The first of those is going to be this rectangle here, and I'll just outline that right there. So I'm going to have a rectangle. And then over here, I've got a triangle. And then I've got a circle. And if I can find the centroid of each of these three shapes, and I combine them, then I can find the centroid of the overall shape. And we're going to do this for both the x and the y position. Now, the x position is going to be really easy for all of them. Okay, so for the x position, x bar, well, let me step back. Remember, x bar is equal to the integral of x dA over the integral of dA. And so this is x times the area, and then the denominator is just the area. So that's what I'm going to take advantage of. So x for the rectangle, okay, so I'm going to take x of the rectangle, which is c over 2. Okay, I'm going to take advantage of the fact that I have symmetry here. And so the top of this rectangle has a length of c, so the bottom of the rectangle has a length of c. A goes all the way across. Okay, and so c over 2 would be the position of the centroid for the rectangle, the x position. And then I need to multiply that by the area of the rectangle, which is b times c. So there's the rectangle. Then I have the triangle over here. And if I look into, there's not symmetry here, but if I look in the back of the book, I find that the centroid of a triangle, the distance above the base of the centroid is going to be h over 3. If the height of the rectangle is h, the centroid is at a distance of h over 3 above the base. Now, if it's not symmetric or nice, that's the only thing I can find. I'm going to have to rotate it and figure all sorts of stuff out to find out the other places where the centroid might be. But above the base is h over 3. So, excuse me, as I'm looking for the x centroid, I'm going to have it somewhere in this area where this is h over 3 and this is h. Well, I can find h, right? This is a, and this much is c. So this distance in here must be a minus c. So that distance must be a minus c. So I'm going to say plus a minus c, and then I divide that by 3. So this distance right here, if h is a minus 3, that's going to be a minus 3, excuse me, a minus c. This is a minus c. This is going to be a minus c over 3. And then I need the area of the triangle. That's 1/2 base, right? So 1/2. The base is a minus c. A minus c, and the height is b. So there's the centroid then for the triangle, and then the area of the triangle. Now I need the circular hole, and so that's going to be right here at the center. So I'm going to assume that I've designated the center of the hole on this line joining the rectangle to the triangle. That's going to be stipulated in the problem. So that's at the position C. So the centroid of the circle is at position C. And then the area is pi r squared. And let's just assume that the diameter of B, and this would be given in the problem, I shouldn't say assume. Let's say it's given in the problem that the diameter of this is B over 2. So pi times the radius squared. So that's going to be pi times the radius, which is actually b over 4, Right? If the diameter is b over 2, then the radius is b over 4, and I'm going to square that. So it's c, the position of the centroid, times the area. Okay, now, the thing is that this is a hole that's been cut out. So instead of adding, I'm going to subtract, because I've taken away that area. I didn't add the area on, I've taken the area away. And then the denominator is going to be, what, b times c, that's the area of the rectangle, and then plus 1/2 a minus c times b, that's the area of the triangle. This is the area of the rectangle, area of the triangle, minus the area of the circle, which is c, no, it's not c. It's going to be pi b over 4 squared. And we're not going to simplify all of that because that would be really hard. Okay, but there it is. So there is the x bar for this composite shape. There's the x bar. Now what about the y bar? Well, that's not too bad. So y bar, same way. In fact, the denominator is going to be exactly the same. So bc plus 1/2 a minus c times b minus, again, because you're subtracting it, you're taking it away, b over 4 squared. Well, so the height, the y position of the rectangle's centroid is b over 2. Right, so that's going to be b over 2. And then I multiply that by b times c. That's the area of the rectangle. And then the centroid of the triangle is going to be, the height is b, so the centroid over here, this distance right here, that's going to be b over 3, right? Because it's 1/3 the height. So plus b over 3, and then 1/2 a minus c times b. There's the area, right? There's the centroid, there's the area. And then the circle, and the circle is going to be b over 2. So plus b over 2, because it's halfway up, times that area, which is pi b over 4 squared. Okay? And so combining all of this, so I have numbers in there, but I'm just doing it arbitrarily. Combining all of that, and I'll have the y position of the centroid for this composite area. All right? So that's how we find, remember, an integral is a sum. So you just do summations based on this integral. You're just going to do summations. All right. In the next video, we'll take a look at how to find the centroid by using integration. Okay? All right. If you have any questions, leave them in the comments below. Thank you.